We are starting the last question of this paper, one of mechanics 9709 oblique 4 to May June 2023. Two particles P and Q of masses 2 kg and 0.25 kg respectively are connected by a light inextensible string that passes over a fixed smooth pulley. Particle P is on an inclined plane at an angle of 30 degree to the horizontal. Particle Q hangs below the pulley. 3 points A, B, C lie on the line of the greatest slope of the plane, which AB is equal to 0.8 meter and BC is equal to 1.2 meter, as shown in the diagram. Particle P is released from rest at A with the strings taut and slides down the plane. During this motion of P from A to C, Q does not reach the pulley. The part of the plane from A to B is rough, with the coefficient of the friction 0.3 between the plane and the particle P. The part of the plane from B to C is smooth. Find the acceleration from A to B of particle P. So there are two particles P and Q which are shown like this. This is particle P there. This is particle Q there. And the mass of this part, it is moving from A, then towards B, and then towards C, which is making an angle of 30 degree with the horizontal. The coefficient of mass of the particle P is equal to 2 kg. The mass of the particle Q is equal to 0.25 kg. The coefficient of friction between A to B is 0.3, and the coefficient of friction from B to C is smooth. The angle is 30 degree there, and you are going to find out the acceleration from A to B of that particle. So this is the question statement of that. From the words of that, the strings is being kept taut and it hangs freely. So we know from this figure here is the particle P there, and this is particle Q of that. The tension between these two strings is same there. If we resolve the forces of P, it should be R, it should be mg cos of 30, and this should be mg sine of 30. And since it is coming downward, so the friction is moving upward to that part there. So for this particle P, we know that this driving force minus the resistive force is equal to ma. So driving force for this particle is mg sine 30 minus tension, and the frictional force is acting as a resistive force to both Mass of that particle is m of p into the acceleration a, which we are going to find it out there. Then for the particle q, this weight is acting vertically downward to that. So tension minus weight of q is equal to mass of q into acceleration a there. So this is equation number 1 and this is equation number 2. Now we put the values into these two equations. Here mg sine of 30 minus tension plus frictional force, which is equal to mu r, is equal to mass of particle p into a there. But frictional force is equal to mu r. Mu is given to us, which is rough between a to b surface, and that is 0.3, and r is basically equal to mg cos of 30. So this will become mg cos of 30. So if we put these two equations in equation number 2, then 2 will by that it should be equal to mg sine of 30 minus t plus f, which is mu r, and that is equal to 0.3 mg cos of 30. That should be equal to the mass of that particle is 2 and acceleration of that particle is a there. But tension is from this equation number 2. That thing is equal to weight of q plus mass of q into a. So from this equation, so we can put into this form, that is mg sine of 30 minus tension is basically equal to mass of q. Mass of that particle is 0.25 kg. So that is 0.25 into 10 plus m, mass of that particle is 0.25 into acceleration a there. That should be equal to, this is tension of that, plus 0.3 mg cos of 30. That should be equal to 2a there. Now we put the values here. Mass of that first particle is 2, g is 10, sine of 30 is half, minus 2.5 plus 0.25 a plus 0.3, mass of that particle is 2, g is 10, cos of 30 is root 3 over 2. That thing is equal to 2a. From this, it should be equal to 20 over 2 tenth minus 2.5 minus 0.25a minus 3 to the 6th and 6. Cos of 30 is root 3 over 2, and that thing is equal to 2a. Or finally, should it be equal to 10 minus 0.2.5, 7.5 minus 3 root 3 is equal to 2a plus 0.25a there. Our a finally is equal to 7.5 minus 3 root 3 divided by 2 plus this 2.25, and that value is equal to, if we use calculator here, So acceleration is equal to 1.023 meters per second square. So that is the first part of that question there. Now for the second part, hence find the speed of P at C. Since we are going to find out the speed at C for that particle P there, we know that u is equal to 0, and we will first find out the speed at B there, where acceleration is already going to be calculated equal to 1.023 meters per second. So we know this formula there, that v square minus u square is equal to 2as, where distance from A to B is 0.8 meter. So v square we are going to find out, minus u square is 0 square, is equal to 2. 8, the value of A is there 1.023 into S is 0.8, or v square is equal to 1.63 6, and v is equal to 1.28 meter. But this is the speed at B there. Now you have to find out the speed at C there. This thing we are going to calculate. But we know one thing, that this velocity at B will become the u there. And that is equal to 1.28 meters per second. And final velocity v is going to be calculated at this position there. But the distance between these two is 1.2 meters. Now we need the acceleration from B to C. So for the acceleration from B to C, because it is a smooth surface, the coefficient of friction is equal to 0. And then we can find out the same situation there, that for this particle, the driving force is mg sine 30 minus tension is equal to mass of that particle is 2 into acceleration A there. That is for this particle P there. And for the particle Q there, tension minus weight of that particle is 2.5 is equal to 0.25 A there. Now we add these two equations. This minus T and plus T will be cancelled out. Mass of that particle is 2 into G. 10 into sine of 30 is half, minus 2.5 is equal to 2 plus 0.25 into A there. So this 7.5 is equal to 2.25 A, or A from B to C is equal to 3.33. meter per second square. Then V square minus U square is equal to 2AS. V is going to be calculated there, where U is basically the speed at B there, which is 1.28 whole square. That thing is equal to 2 into acceleration of A, we have got it equal to 3.33 into the distance between these two is 1.2. So V square is equal to 1.28 whole square plus 6.66 into 1.2, or V square is equal to so this is 9.63, or V is equal to 3.10 meter per second. This is the speed at C that is going to be calculated in this part. So we are going to find out the final speed at C, which is equal to 3.10 meters per second. And now they are going to find out the last part of this question. Find the total time taken from P to travel from A to C. So we have two equations here, one from A to B and one from B to C. We know that if we use this data into this calculation, then the total time taken for this C particle is the time is taken from T1 plus T2 is the total time taken from A to C, where T1 is the time taken from A to B and T2 is the total time taken from B to C. We know that from this equation, we have this V is equal to U plus AT, where V we have calculated equal to at B, that is 1.28 is equal to U is 0 there, plus acceleration for this particle A from A to B is equal to 1.023 into time T1. So the time T1 will be equal to 1.28 divided by 1.023, and that is equal to 1.25 seconds. And then from the B to C, again we can use the same equation of motions there. V is equal to U plus AT, where V is final at the C position. That is going to be calculated at 3.1. U there is 1.28 plus acceleration for that particle is going to be calculated equal to 3.33 into time T2. So the time T2 will be equal to 3.1 minus 1.28 divided by 3.33, and that thing is equal to This time is equal to 0.545 seconds. And now the total time will be equal to T1 plus T2. T1 is there equal to 1.25 plus this time is 0.545, and this total time taken from A to C is equal to 1.79 to 1.8. So this is the final time from A to C for the particle traveling from on an inclined plane, which is making an angle of 30 degree to the horizontal. So this is the last question, 7 of that paper there. We have solved it. So if you have any problem, then you can ask